So I recently found this Cad Practice Book. It was made for AutoCAD, but I'm going to be going through with FreeCAD, and it's from the Source CAD people. So I've got a FreeCAD pulled up here. We'll check I'm running version 0.19 and revision 24.36.6. So let's see, this book has kind of three sections. The first one's 2D drawings, skipping those, going to the 3D practice drawings. And the first part here looks relatively straightforward. I'm going to go over to FreeCAD, move over to the part design workbench, create a new body and then a sketch. And then I'm going to put the origin of this body at the very back corner that you can't see it behind the part there. Okay, so put a sketch on this face, and this first face here is just a square, so we'll make ourselves a square. And the vertical dimension, Shift V, and it is 8 tall. We're just going to be using the standard units here since these don't have units on the drawing. And then the horizontal dimension for this is a 10. And pad that a 2. Okay. So moving on to the second face. Second face is just a square with a rounded edge here. So I'm going to get myself the square tool again and get us the chamfer tool. Okay, so now that we've got a round, we will radius that at 5 and then dimension the height, except it's Shift V instead of Shift H. Got myself confused here. The H in height, except I dimensioned horizontally. And then we need to reference, because this edge here intersects this edge, but it doesn't go all the way back to the origin. We actually have to grab the dimensions. Use the grab dimension tool, and you can grab the points off of this other side here, and we'll coincident those with the C button. Then we come down here, horizontal dimension, this is 20 minus 2, so 18. It's 18. Okay, pad that is too thick. And then get moving to the last face. Okay, this one is a box with a chamfer on the side of it. So I will be grabbing the line tool. I'll draw myself a box with a chamfer on the side of it. Okay. Make this vertical, horizontal, vertical, and then we need to grab a couple of faces to reference here. This one, this one. We'll put that one in the corner. These two are the same point, and likewise for this a third set. And then we need to dimension this 15 down here. So this one is 15 minus 2, 13. And then this last one here is 5 minus 2, 3. Alrighty. And then this is too thick. So, I mean, a relatively straightforward part. It's kind of nice for learning person, beginner, because it'll teach them the basics. And let's move on to another part. Let's see. This one looks relatively straightforward also. Come over here, hide the body with a space bar. Get ourselves a new body button, and we will sketch. And for this one, I'm going to sketch this face here first, extrude it that way, and then we can come down here and cut these out. So I think this is a pretty straightforward part once again. Let's see. Is this one? Yeah, I mean, it's kind of funky shaped, so go ahead and use the line tool. And, oops, missed a face. Okay, go ahead, horizontal, vertical, get our fillet between those two edges. Radius with Shift R, radius of 1. Oops, this is not horizontal. So then from the origin over here, we have 10 units. And ended up on the wrong side. We are 1 unit tall. Mention that. And then this one here, 6 units tall. Starting to take shape. Horizontal, 1 unit. And then this one, horizontal, 5 units. Let's see, you need to be vertical, and we are fully constrained. Go ahead and pad this, pull it off the drawing there. It's a 5. Okay, so we're going to move on to cutting these 2 pockets and then 2 fillets or rounds. And since these are both on the same face, I'll just put these both into the same sketch. You could use the sketch tool, or alternatively, you could use the fillet tool. So for this, I'm going to grab a few lines here. So we have stuff to dimension from. And grab an arc tool. Oops, I want the other arc. Put an arc there, arc here, and make these 2 tangent with the walls. And we'll make them equal. And let's see, they both have a radius of 1. And then grab 2 circles. We'll make them vertical to one another and equal. And they have a diameter of 1. See, that's the diameter symbol. Oops. And come up here. The diameter hidden behind the radius is 1. And then they wanted 4 from this edge here. So grab that edge. This horizontal. Oops. Okay. Try it again. Horizontal, 4. And I'm pretty sure that these are supposed to line up with the fillets. So we'll line those up. They didn't actually dimension them on the drawing, so it's kind of unfortunate, but we'll hope that that's okay. And then lastly, I'm going to play connect the dots here, get the edges of my fillets together. If you didn't do this and you tried to extrude it, I expect that it would only grab the circles, or it might not extrude at all. So then we'll cut, dimension through all. Okay. And that is those. Let's see. So then for this final face here, I'm actually going to switch myself over to the blender movement. And this face here, let's see, we will sketch on you, and we want a circle. So now we can see, let's see, this circle is, it's kind of dimensioned funny. They're dimensioning to some hidden lines, and I guess you're just supposed to assume that this is dimensioning to the center of the circle. It's kind of an odd way to go about it, but we'll assume that for now. So we come over here. The edge of the circle is what they're dimensioning to. Now I am going to dimension to the center of the circle, because dimensioning to the edge of a circle can be kind of sketchy, because like I can put a point here and I can tell it to be on the edge of this circle, but you know, program doesn't know whether it's supposed to be on this edge or it's supposed to be on the other edge, you know, over here. So it's difficult and it can lead to some headaches. So I'm not going to do that. And instead, I'm going to do the math and dimension to the edge of the circle, or the center of the circle. So we can see the center of the circle is 3.2 away from this top edge. We'll grab a reference off of that top edge, and then horizontal dimension 3.2, dimension the diameter of the circle. Oops, we're just talking about how they did it not very good. I would assume that this is in the center. They didn't dimension it, but it's okay. You know? So we'll put a point here. Use the symmetry constraint to put the point in between these 2 points. And then horizontal constraint between this and the center of the circle. And then get out the calculator in order to calculate the dimension for the circle. So 3.2 minus 1.8, so it gives me 1.4 as the radius, so that means 2.8 should be the diameter. And that looks about right. Close this. We will pocket cut, and let's see, here is where they dimensioned the depth of this to a hidden line. It's not great. I'm also noticing this is a terrible way to do this. The dimension is like inside of the part. How am I supposed to tell that that's not, you know, part of the part? Anyways, this is 1 deep, and then a 0.2 radius fillet. Use the fillet tool here. Oops. Edge, fillet, and 0.2 righty. There we go. So this part also relatively straightforward. Not super difficult. Let's see. This one, I mean, this one's complicated. I'm gonna skip it though, because it's I mean, it's just, you know, one drawing here, make this shape, and then you know, a second sketch, make that one, third sketch, make that one, and then you mirror it over to the other side. So not too difficult, it's just time consuming. Let's see. This one, I mean, same thing, I'm gonna skip it because, you know, this sketch you make here, and then you make this other sketch, extrude cut all the way through, and then you can extrude cut this bit out, and then you're done. So not super difficult. Oh, this one is pretty complicated, it seems. I guess it doesn't look that way, but you've got this kind of weird corner chamfer that is 3 on one dimension, 2 on another, 2.5. So pretty odd part. Let's see if we can do this one. Come over here, hide that body with the space bar, grab myself a new part. I'm going to create a sketch on the top, and this part is a box with a fillet in one corner. So radius 2, and then the overall horizontal is 5, the overall vertical 6, and then I'm just going to lock this over to the origin. Okay, pad this at C4 tall, and I'm not sure if the chamfer tool will be able to take care of this for us. I guess we'll see if this works, or see if we have to do it the old-fashioned way. Let's see. Yeah, it looks like it's not doing anything. It wants us to select some edges. So we'll go about this the old-fashioned way. So make a sketch here, and I will grab a line. What I'm going to do is I'm going to sketch out this point, and this point, and I will use that to make a plane, and then I will use the plane to actually remove this section. So seems relatively straightforward. Hope it is as easy as it seems. Let's see. Vertical So we're looking at this from the top. That is a 3. This one here is 2.5. And then I need one more face with one more line. I'm going to get a reference off of this line. And vertical 2. Okay. So now if we hide the pad here with space, you'll see that we've got this kind of 3 pointy line bit floating here. And we should be able to come up here, get the reference tool, and then select these 3 points as the reference. Oops, looks like that did not work. So let's try again. Reference 2, reference 3, alrighty. And if we bring back this pad, you'll see that it's actually chopping through the part at that angle. And then I think we should just be able to extrude cut this through all. Okay. Extrude cut through all. Alrighty. And then we come back, hide the sketches, and you'll see we have that shape. So not super complicated. It's just, you know, there's a little bit more to it than some of the other shapes. So let's see. This one is more complicated. It's not super terrible though. So it seems like you would extrude. This is kind of odd. There should be a line here, and this bit here for third angle projection should actually be over there. But aside from that, and correct me if I'm wrong there, but I'm pretty confident there should be a line here. But aside from that, it seems relatively straightforward, right? So you sketch this face here, and then you extrude that, and then on top of that you sketch kind of this odd circle face, and you extrude that, and then, you know, 2 more sketches, or I guess 1 sketch and then a mirror, and you've got this part done. So moving on to the next one. Let's see. This one is interesting. I'm gonna go ahead and do this one. It's not complicated. It's just kind of an interesting way of doing things. And I guess specifically, I'm talking about this fillet, because you notice that you can't actually make this fillet with the fillet tool because it's not tangent. Oops, that's not a very good arrow. Because it's not tangent at these edges right here. It's only actually tangent kind of in these corner bits here. So kind of an interesting shape. It's quite an odd number, 34.64. Nothing special about it. It's just kind of interesting they'd pick such a specific number. But anyways, go ahead and make ourselves a new part, a sketch. I'm not quite sure what happened to my planes. Oh, I was just super zoomed in. Okay, go ahead onto this one, and I believe we just have a tool for making this. Okay, perfect. This is much smoother than I had expected. So vertical dimension here, 34.64. And then grab ourselves a circle, put the circle in the middle, and then we'll radius dimension this to be 25.2. Let's see, not quite sure where that went. Oh, it must be my circle's not on the center, and that's why it's not fully constrained in green. Okay, we'll pad this to 14, and then I'm actually going to grab a second sketch off of this face here. Find the sketch button. I'm going to use this button here, which is the cut view button. So you can see it chops my view in half and removes everything that would be in front of your sketch plane. I'm going to grab this and grab this top plane, and then I'm going to draw myself a fillet. And be tangent there. Oops, did not like that. Tangent, tangent 2.0, and a radius here, R4. I'm not sure why they call out both sides here. I mean, I would assume that, oh, I see. So this is saying fillet on the top and fillet on the bottom. I was a little confused because I thought they were going fillet on the left and fillet on the right, but in fact there's fillet all the way around. But that was not the case. This is okay. Fillet on both sides. So now we could draw the fillet in on both sides, or we could use the mirror. I think I'll try to use the mirror. And if that doesn't work, then I'll put the fillet in on both sides. Okay, so we've got this thing, little fillety bit, and I'm going to revolve cut, groove. Is that correct? Hey, look at that. Let's see. Doesn't seem correct. Maybe, let's see. Maybe if we just use the regular fillet. Although I can't imagine this is done with the regular fillet. Kind of an odd shape. Yeah, I'm pretty confident this is not using the regular fillet. Let's see, maybe I messed up something with my sketch. This fillet. Let's see, we'll cut away. If I can select the fillet for a diameter. Oh, we're using the diameter tool for some apparent reason. Let's see if I can get rid of this thing. Okay, so it must be related to this. 4. Okay. Oops, not a hole. This groove. Okay, that looks better. That looks better. Alrighty. And then let's see, in order to mirror this, I'm going to need a plane to mirror it around. And the plane's going to be offset from this XY plane by half of the pad distance. So let's come over here, grab ourselves a plane, and then let's see which one of these directions is the correct direction. Looks like it's this one, and I want to offset this by pad dot length. And what this will do, oops, that's not the right distance. So, oh, this is pad 005. What this does is it'll go and grab the pad length, so the length of the pad, and if you change this, then it would update. Right, we do pad length divided by 2, and guaranteed that is right in the middle. I'm going to hide the origin since we don't need that, and come up here, the mirror tool, and mirror this groove. And we want to mirror, select reference, this one. Okay. We can hide this plane, and you can see we've got ourselves this nut. Alrighty. Moving on. So this one, let's see. I mean, it looks complicated, but it's really just a couple of extrudes or pads. So, I mean, what I would do is I would start with this kind of funky face, and I would extrude that, and then you've got kind of this bit here, this cylindrical bit, and then after you do that, you can extrude these two kind of upper parts, and then you can mirror the whole thing over to the other side. And I guess we're just supposed to assume that it's mirrored because these bits here aren't actually dimensioned. But other than that, you know, relatively straightforward. So we'll skip that one. Let's see. This one looks pretty complicated, but I don't actually think it is. It seems like you've got a kind of profile here, and you revolve it, and then you've got this kind of cut that you do in this bit, and a cut through the side. So I'll see. I'll go ahead and do that one. It's kind of interesting. We haven't done a revolve one yet. So hide my body and get myself a new body. Get myself a new sketch. We will pick a plane. Okay. And then I'm going to do just exactly what I said I was going to do. For this, I'm going to use, let's see, I'll use the line tool since it's kind of a funky shape. And then I'm just going to model the bottom half of it. The other half will get created when we revolve. Alright, that there. Let's see. I'm going to say that that's a vertical line. It's kind of difficult to tell. They don't dimension any type of kind of curves in there. So just assume that that is straight. This one horizontal at 19, and then here not like that, here to here horizontal 47, and then the big one at 70. 7. Okay. So then the total diameter of this here, 25. So I'm going to dimension the diameter. It's 25 divided by 2. And then this bit here, let's see, they're, I guess, dimensioning to hidden lines again. It is this thing here, I believe, because it might have been this outside one, but you can see on this set of hidden lines right here that they actually go out to this outside one. So this outside bit here, this outside hidden line, is actually this section here that you just can't see because it's hidden behind the kind of tail feather part of this. So we will dimension here, and this is going to be a diameter of 20, and divided by 2 since we're only dimensioning half of it. Then this part here, let's see, I guess we're just supposed to assume that this bit here and that bit there are horizontal, because I don't see anything dimensioning this particular section of it. They might be like, oh yeah, this thing here, well that covers both this section here and that section there. It's kind of difficult to know though. So we'll grab this horizontal, and then this last section we've got a dimension at 40. So we'll dimension at 40 divided by 2, and fully defined. Take this, revolve it. Didn't quite pick the correct direction. We want to revolve around the X direction. Look at that. Pretty close. So a couple things we need to do. Got a sketch on this back end here. Grab ourselves a circle tool. I'm going to dimension this kind of circle bit here. And that circle bit, you'll notice here, actually goes all the way through the model. So that's why I'm not going to be dimensioning these kind of thin cutout bits just yet. This, grab the, oops, not the angle, but the diameter, and we will dimension that at 13. And cut through all. Okay, come back to this face, a new sketch, and then let's see. Yeah, so we've got a cut here, and I'm going to grab the symmetry tool, make this symmetrical around that, and then the width of this, let's see, is right here at 2. Okay, and for the rest of it, I will just put this and that as vertical, and then I grab a reference off of this bit here and make this and that as tangent. And I will extrude cut this to a depth of 44. Alright, and then I'm going to, let's see, I believe polar pattern is the correct one. Polar pattern this pocket, and then I want the x-axis. And we want 3 of them. Okay. So there you go. This thing, one bit left, is this hole here. So I'm going to bring back the origin. Now you'll notice that this hole lines up with one of the fins, and I'm going to pick this face here because it's the one that lines up, and that's easy. So let's see, looks like we're actually around the back, but that shouldn't make a difference for this. I'll cut and grab the pocket tool, I guess slot tool, and our slot is 5 tall, so dimension this at 5, and then center to, let's see, yeah, so we've got the 2 sides of the slot dimensioned individually. So that should be relatively straightforward. Just come over here. Notice the origin of the sketch is actually in a pretty good spot. So horizontally dimension this to 4.66, and then grab this and horizontally dimension that to 12.66. Alrighty. And then we shall pocket, dimension, 2 dimensions, and quite large. There we go. So that is that one done. And let us see. So this is an interesting little one. It is relatively straightforward. So I mean, what you would do is, you know, you'd make this kind of a regular pipe as you normally would, and then you make a kind of funky plane off here out in space to dimension this bit, and then you extrude that back, and then you just cut 2 of these holes in, and you call it good. So pretty straightforward. I guess they do have some interesting fillets here, but I think we might come back to this one. I'm not sure. I'll have to think on that. Let's see. This one, I mean, this one's just a bunch of pads, so I'll leave it. It seems pretty straightforward. This one looks kind of similar to a castle nut. I guess this would just be a combination of the nut we made earlier, and then you've just kind of got this weird cut feature out, and that's just been mirrored a couple of times, or I guess polar, let's see, what's it called? Polar patterned a few times. So we'll skip that. Oh, and I guess another big difference on this part here is that instead of a a fillet on this face. It's a chamfer, 30 degrees, but overall it's the same process. So we'll skip that one. This one, we'll skip this one. I mean, it's just a bunch of pads. So this one, I mean, it's kind of an interesting feature, but I mean, ultimately, you can look at this one two ways. Either kind of it's a pad, a big pad, with kind of all of these features into it, and then you've got this kind of center cutout, and then you've rounded a couple bits, or it's a like kind of revolve, and then you've modeled one tooth, and then you polar pattern all the way around. So two ways to look at it. I'm going to skip it because it looks like it would take quite a long time. Let's see. This one is kind of interesting. Might go ahead and do this one. This one's kind of more complicated. It's different from the other one because this section here is curved, so you don't use the pocket cutout tool. You'd have to use one of these loft tools. But overall, you get this bit here, extrude it, extrude these two bits down here, and then you make a circle and extrude that all the way through, and then you kind of get this cutout on the bottom here, and that gets extruded up. So I don't know, let's go ahead and do this one. This one seems kind of interesting. So hide the old body, grab myself a new body, and a sketch, and pick this face. So now on the top here we are two circles that are equal in size and these numbers are quite large. Let's see. I guess they're dimensioning the circle using this 1/76 dimension, which is okay. We can do that. It's kind of odd. So once again, that's dimensioning to the outside of the circle. It's kind of awkward, but we can calculate the center of the circle by doing this 133 and 57, just the average of the two. And that gives us 95 from the center. So let us see. Horizontal, 95. Guess we were pretty small in comparison. And then we can do 133 minus 57 to get us the diameter of the inner circle. And that would be 76. So pretty big. And then let's see. We can do 133 minus 176 to give us the distance between the edge of this circle here and that one there. and we can multiply that by 2, so that's 43, multiply that by 2, and then add that to our dimension here. Let's see, what was this? This was 76. So we got 86 plus 76, which is 162 as the diameter for the big circle. Okay, and then I'm going to symmetrically constrain the other half. And then they've got this this box in the middle. Now it looks to me like this box is like, how do you say it, one with the circles, but they've got like the lines on it here, so I don't know, I'm kind of confused. I guess that's maybe so that they can dimension it here, but I don't know. I believe that is correct, but we'll see. And like, once again, with the dimensions on the inside of the part, makes it very difficult to read. So grab the box tool, put a box there, and vertical is 50, and horizontal, like, I'm not even going to dimension that part because this, and like, I'll explain why. Okay, so this 80 here is dimensioning to what? Because like, this thing is completely flat on top, right? So like, if you were to manufacture this thing, like this little bit here wouldn't exist, right? So there's not really any reason to be dimensioning that, you know? And then I guess we assume that this is, I guess, in the center line with the circles. But I think that's an okay assumption. And then I'm going to make the box symmetrical. And then here we're going to have an issue because it's not going to know what to extrude. So I'm gonna get rid of some of these bits. And then you might have to go back and reconstrain a few things. So let's see. Oof. Looks like this and that came unconnected. Okay. We'll pad this, and this is 32 thick. And then, let's see. Out of the bottom of this, I think I'm going to, let's see, what do I want to do first? I'm going to do this section here next, and then I'll do this kind of bit here, right, where it comes up and joins with the rest of it. And the reason that I'll do that is because if I do that, then I can just extrude it up here some amount, and then when I come through with this kind of sweeping extrude and cut, it'll clean that up. Otherwise, if I did it the other way, so if I did the sweeping cut first, and then I extruded this up, I'd have to worry about lining the extrude for this bit up with this funky curved surface. So that doesn't seem like it would be much fun. So I think you can use the, let's see, the up to surface command when you go to pad something. But you know, I'd rather avoid kind of odd commands like that where you're just trusting the computer to do the right thing. Because especially with these kind of surfaces that go all the way around, it can get pretty funky. So I try to avoid that as best I can. So in order to do this, I'm going to need a plane, and let's see. They dimension it from the top, so I'll do that also. And they want it minus 2, minus 220. Okay, over here we'll zoom back in. Alrighty, so got my surface down here. Going to sketch on that. And here I'm going to have another issue because FreeCAD doesn't appreciate it when you have two bodies in one body bit. So maybe let's see. Maybe we try this up to surface thing and we'll see if it works, and if it doesn't, then we'll do some funky stuff with like two bodies and Boolean combining and subtracting from one another in order to make this. Turns out to be a pretty interesting part. So I'm going to go ahead and hide this plane since I decided not to use it. And let us see. So I am going to, let's see. So what I see here is you've got kind of this lip bit, which is just a normal pad, but you've also got this kind of curvy part which actually starts before the lip bit. And if we zoomed in here, I think we would see that it would be kind of funky. Because this, you see this lip bit here is kind of odd, right? You've got this little gap in between the two of them where there's nothing. So I guess we'll try to do the same thing, but seems not like what you would want if you were making some part. Anyways, this thing over here. So in order to do this, I need two things. So I need a sketch, and I'm going to grab this here so that I can put a circle onto it. And we'll do two circles because we got to do one for the inside and one for the outside. You could do it in one shot here because we're not actually removing anything. If I had extruded this up before, like I was talking about, I would actually do this in two separate passes. I would do one loft and then one like cut loft through the center of it. Since we're not doing that, this should be fine. So let's see. And they're doing something funky again here. So you see this dimension, the 63 and this 127, dimensioning the outside and inside of this. Well, that's how they're dimensioning the actual diameter of this bit. So I'm going to do some math again. I didn't realize this would be a math lesson, but let's see. So we did the average of 63 and 127. It gives us 95 as the, let's see, yeah, as the diameter for the inner circle. So 95. Okay. And then the outer circle, same thing, but with this 45 and 145. Which gives us, oops, I did something wrong. Let's see, well, I'm getting 95 again, so I must have messed up on my math somewhere. Oh, yeah, we should be subtracting them. So the outside is 145 minus 45, which would be 100, and the inside is 127 minus 63, which is 64. So the outside of 100, maybe I'm messing something up again. Does not seem correct. Let's see. So 63 minus 127 should be diameter. So it should be 64. Maybe this is right. I think I was getting myself confused because it appears that this is kind of pretty close to the edge here, but that's actually this lip here. And the rest of this is not super close to the edge. So we'll roll with this, and if it turns out I mess something up, I guess we'll find out. So close this, and then I need to make another sketch that we're going to be extruding this along. So I'm going to put it on this face, and I'm going to grab the circle here from my previous sketch and put a point at the center of that line. Okay, and then I grab this circle here and put a second point at the center of that line using the symmetry tool. And then I will grab myself an arc between these 2 points. And then I want this one to be perpendicular. Let's see, perpendicular. Okay, so now we should be ready. And grab the, let's see, don't want that one. Sweep a selected profile along a path. I believe that is the one we want. Oops, except that's the cut path. We want that, but we want the extrude path. Okay, and there we go. So now I'm going to do one more sketch on this face and make the little flange bit. We'll call that good, and we'll move on to the bottom section. So once again, grabbing these two bits and I'm going to cut away so I can actually see what I'm doing. Do this and this. Make the two sides equal. Okay, and then let's see, where do we dimension this? So I believe they're dimensioning it using this 20. So it's 20 from the edge. Let's see. Yeah, that appears to be where they're dimensioning it. Okay. So, let's see. Grab the dimension tool and come up here. Somewhere there's a measure tool. Might have to back out of the sketcher. Figure out how big that original pipe was. So it was 162 millimeters. So we know that it's 20 from the edge, so 40 from both edges. So 162 minus 40 should be the correct diameter. Diameter 162 minus 40. Okay. And let's see. They don't pick a diameter for the inner one. So I guess we'll just assume that it starts at the same spot as the curvy pipe bit. Which would be, let's see, grab the tool. This is it's a difficult thing to select. Here, let's come back here, turn off the pipe, and we'll look at the sketch we had before. And we'll grab that from the sketch. Get rid of that. This and that are equal. Okay. So, should be good. And it is fully constrained. Extrude here at C14 deep right there. Extrude 14. Don't know why my model has moved off the screen. Oof. That is not looking great. So appears to be a glitch. Let's see. If we cut away this and come down here, get rid of this final equals. We'll just make it a little bit bigger. See if that fixes our issue. Okay, yeah, so my guess there is the issue it had was extruding. Let's see. So it's got like a face that's coming off of it like this, and then it's like extruding this bit down here. And my guess is it had troubles with this upper corner area. And that's just kind of one of the limitations with the FreeCAD engine, I think. So overall, I'm sure there's a few ways you could have gotten around it. You could have, let's see, I believe you could Boolean combine and get around that issue. The issue really is you end up with this kind of infinitesimally small section up here. And, you know, that's just difficult to deal with, you know, anyways. So, okay, let's see. Moving on to this bottom bit. I think what I'm going to do is I'm going to bring back that plane, and I'm going to sketch on that plane and extrude up to this surface, and we'll see if that works, and if it doesn't, then we'll do something different. So let us sketch on this. I'm going to cut away, and all we need is 2 circles. So I'm just going to sketch the pipe bit, and we'll deal with the flange and holes later. So this outside is 100 diameter, and then the inside, let's see, yeah, I don't see any dimensions for the inside, but I guess we'll just assume that it's the same thickness as the outside. We can get the thickness with 145 minus 127, so it's 18 thick. So I calculate that this one also should be 64 diameter on the inside. Okay. We can hide that plane. Maybe we won't hide it. And let's see. Pad doesn't like it because it would make 2 bodies. Let's just make this number like really big. See if it likes it. Result has multiple solids. We might be going in the wrong direction. So come down here, reverse it. Still has multiple solids. Let's see. Well, it's not liking that pad. Okay. So now, how do we get around this? What I'm going to do is I'm going to group these 2 things together in a part. Put this body under the part, and then I'm going to make a new body. Come down here. Let's see. We'll grab a reference, to this. Okay, now we've got this in the second body, so I'm going to take this and extrude. Let's see, can we do up to face? Maybe. No, it doesn't like that. Up to first. Does not like that either. So we'll just pick a dimension. Let's see, more than 30, more than 60, it's more than 80. I'm feeling that something is wrong, because so the issue I see is that this pipe here is the same diameter as the big pipe, right? But if you look down here, this pipe is actually smaller, right? So this pipe is smaller than that pipe. So I'm thinking I probably messed up something. And that's probably why it doesn't like the up to face, is because you end up with this little infinitely small bit on the side of it. You know, it's like, well, when does that hit a face? Well, probably never. So let me go back here and redo my computations. So radius of 195 on the outside and a radius of 63 in the middle, or I guess 45. So this distance here is 45, and then the big distance from here to here is 145. Right, so this is 100. So this seems odd, because these two things are most definitely the same shape, but they're most definitely the same diameter. And here in this drawing, you don't see that. So I'm thinking this is, you know, they're doing something funky here, because this should really come to a point, and it doesn't. Right, so this bit here should look like that, right? Because it gets infinitely small. So let's see. How do I go about modeling that? So I guess the first thing I'm going to do is I'm going to calculate where the center of this thing is vertically, and I'm going to extrude to that amount. So we're 32 from the bottom, so we're 32. Let's see. So I need the distance from here up to the center of this thing, and that distance is going to be this 32 here. Let's see, or actually it's going to be this 220 minus the thickness, which is 32 from here. Oops. From here, and then we need minus half of this, so the distance between this and this is 63. So that would be minus 63, and then we need minus half of the total distance there, which would be 50. right? Because the pipe is 100 in diameter. So now if I do that math, let us see, 220 minus 32 minus 63 minus 50 would be 75. So I believe 75 is the amount that I need to pad. Let's see, 75. That does not quite seem right. Let's see. Well, I'm going to hide this shape and I'll bring back the pipe sketch, and we'll use the measure tool here. Let's see, tools, measure, linear, measure between this and this, and that says 94, although not quite what I was looking for. So we'll measure from here to here. So that says 93. Okay, so this pad here should be for 93. And that seems a lot better. Okay. Yeah, that looks better. Okay. So, let's see. I will grab this. Let's make this the active body, Boolean operation, add body. I'll add this one. Fuse. Okay. And now that's good, but see, the issue with that is, grab my view, we want to clip on the Z. So the issue is I've got this kind of extra pipe bit in the middle here, right? Because I extruded this up and then I combined the two things together, so I've got this extra kind of box extrusion here, which is, you know, not quite what they were looking for, but that's easy enough to get rid of. So how I'm going to get rid of that is I'm going to come over here, look at this sketch that I made. So this is the sketch that went with the original additive pipe, and I'm going to grab this and I'm going to do a link. So now I've got a shape binder, which is that original sketch in it. We'll bring this back, shape binder, that, extrude, cut. Okay, oops. Let's see, maybe my shape binder didn't work. No, it did. This, cut, sweep path. Oh, I guess it didn't find the edge. Okay, no valid sub element. Let's see. Rotation. I don't know, all of this seems okay. Let's see. I mean, if I take this shape binder, I should just be able to like extrude cut with it. Yeah, so the shape binder appears to be working. I'm not sure what the issue is. Let's see, I suppose we could also use the groove tool, since this is around the center of it. So let's do that instead. Groove, and I want the z-axis. Okay. Resulting shape is not a solid. That looks it looks pretty good. I think we're gonna have to do something similar. It's probably running into an issue because of some geometry funkiness. So what I'm gonna do is I'm gonna get rid of the shape binder. I'm gonna grab a new part, and I'm going to come over to this body, hide this, grab that, shape binder, okay. And then in here I'm going to pad, I'm going to revolve. Let's see, shape binder, revolve, z-axis, 180 degrees. Okay, and I'm going to come back to this part that I hid, and I'm going to make you active. Okay, and then I'm going to Boolean subtract. Let's see. Did not like that. Did not like that. So let's see. Not sure what it's having troubles with. It might be having issues with the fact that it's got kind of these end bits that line up exactly with the end bits from the other side. So let's toggle this one back on and grab both of these, extrude them up just a little bit. That's interesting. Let's see. This, like that, extrude. Okay, so there's obviously something going on with this original shape. Let's see. I might, yeah, let's do this. We'll just, instead of using the shape binder, we will reference the shape binder and do the sketch ourselves. Okay. Revolve, oops, that's not a revolve, this is a revolve. 180 degrees the other way. Okay. Get rid of the shape binder. Bring this back. Now we try our Boolean. Oops. Okay. Boolean. Add body. This one. so body 5 boolean, and we want to add a body. We want, oh, the other body's disappeared. So body 5, body 7, boolean, cut. Okay, so that's boolean cut, but the wrong direction. So we want 7, and then 5, and then boolean cut. That is also the wrong direction. We want 5, and then 7, and then cut. Okay, this has to do with our active body, I would assume. Boolean, fuse, cut. Okay. Now, if we look down the center of our part, view clip-in plane, clip on the Z again, you'll see we don't have that kind of funky pop-out bit. Okay, so then all we have to do is the flange, and call this part complete. So let's see, I'll sketch on the plane again just because it's here. Sketch on the plane, and then I shall cut. Oops, that's not the cut button. Let's see. Alrighty. So then this one here, big bit, and then let's see. I'm gonna do the holes separate afterwards. I think that is the plan. Grab this, connect the dots. Well, I guess there's not many dots to connect, but you get the idea. And this outside bit on the bottom is 115. Oop. Well, they've done this funky thing again. So here they've dimensioned it with a radius. This goes all the way around, even though you can't see it. That should be a diameter. So this is not a radius. This is a diameter. 115. Or it's not 115. It's 115 times 2. That looks better. Should be good. And then we just extrude this up. Let's see the height of 32. And then we've got a couple of holes. We have 8 holes. I would assume they're evenly spaced. I don't think it tells you. It does tell you that they are 19 away. Although that seems kind of unlikely, given this 19 here and this 115 there. I imagine the 19 is much closer to the middle, so we'll probably just make up a number for that. But let's see, so here, sketch, and grab ourselves a circle. This is a diameter of 18, and I shall grab the outer circle as a reference for our bolt circle, and we'll make this one here a reference dimension. And somewhere up here, this button here is the make reference dimension. or change to reference dimension, we will put the bolt onto the bolt circle, and they said it was a radius of 19, which means it's diameter of 19 times 2. That seems pretty unlikely to me. You can see here that doesn't even touch the part. So I'll just make up something that sounds good. How about 115 times 2 minus 18 times 1.5. Oops. Alrighty. It's a little bit flashy. 115 times 2 minus 18 times 1.5. And I'll put the 18 times 1.5 in parentheses this time. That's a little bit close to the edge. Maybe minus 18 times 0.5. Okay, that seems okay. My guess is this is supposed to be 190. Oops, it's not the correct dimension. This one, yeah, 190. We'll make it 190, and we shall cut. And you might want to choose, let's see, through all. Since we sketched on the top face here, the through all makes sense. If you sketched on the bottom face, when you go to pattern this, your through all will actually cut through the rest of your pipe. So do that and get ourselves a polar pattern on this pocket. And let's see, we want to pattern along the x-axis. We want a couple of these things. In fact, we want 8 of them. Oh. Maybe we choose a different axis. Oh, oops, I did a linear pattern. No wonder it's not working. Click the wrong button. Okay. A polar pattern this time. 8 of them. And we want x-axis. Okay. So there's that. Let's see, is there anything that we missed? I don't think so. I think we got everything. It's pretty interesting part. It ended up being a lot more complicated than you thought it would have been. Let's see. Hide that, and there we go. There's our part. Move on. See if there's any more interesting ones. That's interesting, but it's not super difficult, it seems. Like on this one, it's just a revolve. You know, you draw this bit here, revolve it around, and then you'd cut out this section. And they've given you helping guides on exactly how to cut that out, it seems. Yeah, so you'd cut out, this cutout, you know, is a cylinder at a, you know, however many degree angle, 45-degree angle, maybe. Actually, no, that 45 is, let's see, the 45 is this chamfer on the edge here. The angle is that a G? What is this? That's a G. So I guess we'll be skipping this one. I was thinking about doing it, but I mean, if you can't dimension your thing with like numbers, I think we're good to skip this one. But it looks like you take a cylinder. The cylinder is at kind of a funky angle, and you cut a bunch of cylinders out of this thing. That's how you make that feature. So this one, yeah, this one's just a couple of pads. This one's much simpler than the rest of them. I guess the geometry is kind of funky, but overall it's just a few pads. Okay. So this one, I mean, if you've ever made a bolt before, this should be relatively straightforward. It is just a couple of one big sketch, which is then revolved around, and then you put in a helix, right, with these dimensions here, and then you model some of these other dimensions, and then you use the cut helix button up here to cut that into the shape. Overall, straightforward. Diamond knurling. This would be kind of tedious, but you take well, that looks like an arrow, but let's see. You grab a piece, looks like this, kind of at an angle, and you cut through it a bunch. You polar pattern that around, do the same thing, go in the other direction. I believe that's how you make that. Maybe there's a better way to make it, but that's what comes to mind. Although it's not super critical. They don't even dimension it. So let's see. Fan. It seems to be pretty lacking in dimensions, though. Use profile of the fan. Yeah, so they just want you to trace out the top of this, and then I guess just try your best to get this. I don't know. Seems interesting. I might do this one later, but I expect that it's just a kind of odd extrude along a surface or a profile, and then you come down from the top and cut it, and then you pattern a few times to get the other fan blades. That's what I would expect to do, although that's not like the way you'd make a fan blade, I don't think. A tire. This one has exactly 0 dimensions on it. I guess you're supposed to reference a video, so skip that. And I guess that's the end of that. The rest of these are for houses. Oh, look. So I guess it's a good stopping point. I would like to thank Jai Prask Pandni for making this book. I believe he is the maker. I haven't checked. But yeah, well, thank you for sitting through this or skipping through it at your leisure. I hope you learned something. I think in particular this last model probably was the most learning. If you ever have any issues with FreeCAD's engine, FreeCAD's modeling engine, dealing with these kind of funky shapes, the Boolean stuff tends to work very well. So you convert it over to Boolean, model the two things separately, Boolean add, Boolean subtract seems to work pretty well. So thanks for watching. I'll see y'all soon.